Hello and welcome to another math-tastic video here in Mathland. Today we are solving radical equations that are a little bit more complicated here. We need to isolate that radical. Okay, so we've got an example here. I've got the square root of 7 minus 6x inside the radical, square root, plus 3x equals 2. Okay, so first thing we need to do is isolate a radical. Make sure it's the only thing on that side of the equal sign so that we can square it and lose the radical altogether. So I'm going to subtract 3x from both sides. Make sure this guy is the only thing on one side of the equal sign. Okay, so I'm going to bring everything down. I've got 7 minus 6x equals 2 minus 3x. Okay, now this is the only thing on the left side of the equation. So to get rid of that radical, I need to square everything here. So I'm going to square this, and this is now a binomial, and I'm going to have to square that as well. Okay, so let's go ahead and square it. So when I have a radical multiplied by itself, it becomes just the radicand. In other words, the numbers on the inside here. So when I square it, becomes 7 minus 6x equals, now remember that the exponent tells the base how many times you should write it down and multiply it. So I'm going to put a little small here, 2 minus 3x times 2 minus 3x. Okay, and I'm going to FOIL this thing out. So I'm going to go 2 times 2 is 4. 2 times negative 3x, negative 6x, negative 6x again, and plus 9x squared. Okay, so I did all my little foiling stuff, and I've got those terms there. Now I can combine like terms, so I'll do that now. 7 minus 6x equals, I'm going to move my x squared terms first, and my x term second, and the 4, I'll put it on the end just so it's nice and neat. 9x squared minus 12x plus 4. Okay, so I move things around so it's nice and neat. Now I have a quadratic over here. Quadratic means the first term is a variable with a square on it. And I'm going to move everything over. So to solve for a quadratic, remember we need to factor those things and get them down to binomials if we can factor it. Okay, so I need to set it to equal 0. So I'm going to move everything on the left side over to the right side, so I'm going to add 6x here. Okay, and I'm also going to subtract 7 there. So now I have a big fat 0 on the left side, and over here I've got 9x squared minus 6x minus 3. Okay, I've got my 0, I've got a quadratic now. Now we go back to factoring. So 0 should equal something over here. Let's try to factor this. The first thing we need to do when we factor a quadratic or anything is to look for a greatest common factor. It looks like I can take a 3 out of that right there, so I'm going to factor out a 3. Okay, that's the biggest number I can take out of all those terms there. So then I'll have 3x squared minus 2x minus 1. Okay, that's a little bit more manageable to factor from here because we're looking for binomials that multiply together to get this. So the reverse of FOIL. We need to get it down to something that looks like that up there. So a couple binomials. Okay, so 0 equals, I'll bring down my 3, and I should be able to factor this into a couple of binomials. So factors of 3x, that would multiply to get 3. There's only one option, 3 and 1. And then factors of 1 that multiply to be 1. Okay, so then we have to figure out which one has the plus, which one has the minus. So if we multiply 3 times 1 and it's negative, that would give us negative 3. And then we add a 1, that would give us negative 2. Okay, so now our options are within these binomials. Okay, so this 3 doesn't matter anymore. We're solving for x, so we want to know where is x and how can we solve for it. So the law of 0 means that something times 0 has to be 0. 0 can be multiplied by itself or by something else. It will always be 0. So we're going to set these guys to equal 0. 3x plus 1 equals 0, and x minus 1 equals 0. So we make two nice little equations there. They should equal 0. So I'm going to solve. I'm going to move the 1 over and divide by 3. So x equals negative 1/3 or x equals positive 1. Okay, so these are my possible answers that could work for this equation. However, when we deal with radicals, we need to check our answers here because we could have extraneous answers that work mathematically here, but when we actually plug it into the original equation, they might not work so well. So we're going to check these answers by plugging them in here. Okay, so let's go ahead and plug them in. I'm going to try the negative 1/3 first. Okay, so I've got square root of 7 minus 6 times a negative 1/3. Okay, that's a 3. Okay, so I'm going to go ahead and cancel this, or simplify this. So I've got square root of 7 minus negative 2 times negative 1, so plus 2, which is the square root of 9, which is 3. Okay, oops, I forgot the other stuff. So plus 3x equals 2, plus 3x equals 2. Plus 3x equals 2. Okay, so now here we are. Square root of 9 was 3. So plus 3x, 3 times, our x is down here. Negative 1/3 equals 2. Okay, so all of this over here should equal 2. So if I simplify this stuff right here, I'm going to get a negative 1. So 3 minus 1, when I cancel that out, does that equal 2? Yes, it does. So x equals negative 1/3. This one works. Okay, so that's definitely an answer. Now we have to figure out this guy over here. So let's plug him in to the original equation. And we've got square root of 7 minus 6 times 1 minus 3 times 1 equals 2. Okay, so all this should equal 2 if we're playing our cards right. Okay, so 7 minus 6, that's 1. Square root of 1 minus 3 equals 2. So I've got square root of 1 is 1. 1 minus 3 equals 2. 1 minus 3 does not equal 2. That's not right. So this guy is an extraneous answer. So our true answer, final answer, is x equals negative 1/3. So don't forget to check the answers that you get when you solve it into your original equation here. Okay, enjoy!